Here we have a classic physics question in which we have two blocks that are connected over a frictionless and massless pulley, and they are on an incline. And in this case, we are told that block A is sliding down the incline, and it's doing so at a constant speed. One thing you want to keep in mind is when objects are moving at constant speeds, then their accelerations are actually equal to 0 meters per second squared. So that's a fact that we will return to shortly. What we have done first is drawn a free body diagram showing the forces that are acting on block A. We have the downward gravitational force, which we've labeled MAG. We have the normal force, which is basically the surface of the ramp pushing up perpendicularly onto the block. We also have a kinetic frictional force. Notice that since the block is sliding down the ramp, the kinetic frictional force will be pointing up the ramp because it opposes the motion of the block. And then we also have a tension force because the block is connected to a rope, and that tension force points up the ramp. Now, once you've labeled your forces acting on your object, it's a good idea to organize these forces into a table, and we're going to break each force into its x and y components. Now, it is acceptable to use the cosine of an angle to find the x component and the sine of an angle to find the y component, but where students get confused is how to measure that angle. I recommend that you always measure your angle relative to the positive x-axis. So, for example, if you look at the normal force, the angle relative to the positive x-axis for that force would be 90 degrees because it's pointing along the y-axis. So when you put that into the force table, you would do Fn cosine of 90, and then in the y component, you would do Fn times the sine of 90. Now, the kinetic frictional force and the tension force, you'll notice, are both pointing exactly up the positive y-axis. So the angle for those two forces relative to the positive x-axis would simply be 0 degrees. So you can put that into your table as Fk cosine of 0 for the x component and Fk sine of 0 for the y component. Similar with the tension force, you would have tension cosine 0 degrees and tension sine of 0 degrees for the x and y components respectively. Now, the gravitational force is the one you have to be careful about. We were told that the ramp has an angle of 30 degrees. We notice that we have ourselves a right triangle right here, and of course that makes this a 90-degree angle. Now, the sum of the angles of a triangle, of course, is 180 degrees. So if this angle is 30 and this angle is 90, together they make a 120 degree, and then this angle must therefore be 60 degrees. That way, all the angles sum to 180. Now, you're not going to use a 60-degree angle, though, for this force, because, again, you need to measure the angle for the mg force, which points straight down. You need to measure that angle relative to the positive x-axis. So in fact, while we measure out this angle, we would come in a full 180-degree arc right up here to the negative x-axis, and then you would add 60 more degrees until you reach this gravitational force. So in other words, you take 180 and add 60 more degrees on it to get a total angle of 240. So you'll actually have, for your gravitational force, struggling with my colors here, you'll have MAG cosine of 240 and then MAG sine of 240. So once you've organized the forces into the table and you've created their x and y components, the next thing you want to do is find the sum of the forces in the x direction and the sum of the forces in the y direction. We'll focus our attention on the x direction because, as we'll see, that will be sufficient to answer this question. So to find the sum, of course, that means to add all the x components together. So we're going to go ahead and write out all 4 x components added together. So there is the sum of the x components. I suppose we could write that as sigma fx. Newton told us that we can set that equal to the mass of the block times the acceleration. But remember earlier we said the acceleration was 0. So we would actually be multiplying this by 0. So the entire right-hand side of this equation would just become 0. We can further simplify this equation because we know that the cosine of 90 degrees is equal to 0. So this term actually drops out. The cosine of 0 degrees is 1. So you actually have Fk times 1, which will leave you with Fk. Again, the cosine of 0 is 1, so you'll have t times 1, which is just t. And then you have the mass of block A, which was 10 kilograms, multiplied by g, which is 9.8, multiplied by the cosine of 240. You could pick up your calculator and punch all of that in right there. So 10 times 9.8 times the cosine of 240 is negative 49. So you have Fk plus T minus 49 newtons equals 0. Now it turns out that we're going to need to figure out the tension force as well as the kinetic frictional force. We do recall that in this chapter we learned that the kinetic frictional force is equal to the coefficient of kinetic friction, mu k, times a normal force. So we can make a little substitution there. But we still can't find the tension until we find the normal force. And for that, we actually do need to turn to the y direction, because the y direction contains a normal force as one of its forces. So we're going to go ahead and we're going to sum all four of these y forces. We'll do this down below. So here is the sum of the forces in the y direction for block A. Again, Newton told us to set this equal to mass times acceleration. Acceleration is 0, so the entire right-hand side of the equation is 0. We will also notice that the sine of 0 is 0, so these two terms right here drop out. And the sine of 90 is 1, so Fn times 1 is just Fn. So now you have Fn plus this y component is equal to 0. Let's plug in the known information again here. 10 kilograms times 9.8 meters per second squared times the sine of 240. And if you type in 10 times 9.8 times the sine of 240, you're going to get negative 84.9. So now you have Fn minus 84.9 newtons equals 0. Add the 84.9 to the other side, and you can see that the normal force is 84.9 newtons. And so you can take this normal force and you can now go back and plug it in to the equation you had developed for the x components. So we'll take the coefficient of kinetic friction, which was stated in the question to be 0.2, multiply that by our new normal force that we just found, plus tension minus 49 newtons is equal to 0. So now we just have to do a little bit of algebra here to solve for tension. Oh dear. Why don't we add the 49 newtons over to the other side and also multiply this out? So 0.2 times 84.9 is about 16.98. Goodness. Newtons plus tension equals the 49 newtons, and then subtract the 16.98, and you will get a tension force of 32.02 newtons. This is not the answer to the question, of course, but this is a result that we're going to be using. Let's take a look at the free body diagram for block B. So block B was suspended, and there were only two forces acting on it. There was the tension force. You recall that block B was connected to a rope, and the tension force is pulling up on the block, and then you have the downward gravitational force. We've assigned the upward direction with a positive and the downward with a negative. In this case, it's not really necessary to put the forces into a force table because both forces are acting exactly along the y-axis. So we can actually kind of simplify the approach here and just look at the forces in the y direction. Now, again, Newton tells us to take the sum of those forces and then set that equal to mass times acceleration, which again is 0. We have two forces. We have the positive upward tension and then the negative downward gravitational force. Now, what is nice about this is we solved for the tension. So we can actually plug that in here as 32.02 newtons minus the mass of block B, which is what we're ultimately looking for, times the 9.8 meters per second squared, and this is equal to 0. So what you could do is subtract 32.02 to the other side. So you get negative 32.02 over here, and then divide both sides by negative 9.8. And when you do so, you are going to get a mass for block B of 3.27 kilograms approximately. So this would be the correct answer to the question.